Hello everyone and welcome to our additional Lab in a Bag activity. Today you'll be learning more about energy and simple machines and how to make a catapult. But first, some background information to help you out. This week we're going to learn more about energy and how we use it to get things done. Energy exists in different forms like potential, kinetic, thermal, electrical, chemical and nuclear. We will be exploring the concepts of potential and kinetic energy. An example of potential energy is how a rock at the top of a hill has a great potential to fall due to gravity. When the rock is falling, this is called kinetic energy or energy in motion. A catapult is an example of a machine that is a lever. A lever is a machine that is made up of a bar or an arm which turns on a point called a fulcrum. Force or your effort is used to move an object or the load using potential and kinetic energy. Catapults have been around for centuries and were used to launch objects in ancient wars. Today, you'll learn how to create a simple catapult and launch an object. So grab a buddy, grab your lab in a bag, and let's get started. Gather all your materials. You'll need 10 popsicle sticks, 4 rubber bands, 1 plastic spoon, 1 bead or object to launch, safety goggles, and your scissors. Today, Cole is using a marshmallow, and later on in the video you'll see me use the bead. Step 1. Take 2 of the popsicle sticks and cut a small notch or groove on each side of one of the ends of the popsicle sticks. These notches will help the rubber band stay in place. Please be careful as scissors are very sharp, so please get a grown-up to help you with this part. Step 2. Place the other 8 popsicle sticks into a stack on top of each other. Wrap a rubber band around each end of the pile. So you'll be using 2 rubber bands in total, 1 rubber band on each side. Take one of the notched popsicle sticks and push it under the top stick of the stack in the middle. Flip over the stack so the stick you push through is now on the bottom. Make sure the notched stick is halfway through so it looks like a bow and arrow. Lay the second notched stick on top of the popsicle stack and wrap a rubber band around the 2 popsicle sticks that are notched. The area that you notched will help keep the rubber band in place. Use 1 rubber band to attach the spoon to the popsicle stick. Put your catapult in an open area with a sturdy, flat surface, such as a table or an open space on the hard floor. Clear about 1 meter or 3 feet of open space for the launched object to fly and land. Now place your ball in the spoon and press down on the spoon, then let go. Try adjusting the stack of popsicle sticks by adjusting it left to right and see what happens. When you push down on the spoon that's attached to the arm, what you're doing is storing potential energy. When you release your finger from the arm, the potential energy gets turned into the kinetic energy or moving energy. This is what causes your object to launch. Now it's time to build, test and redesign like an engineer. This is where we want to try again. So what can you do to the catapult to change the distance the ball travels? Where should the pivot point be positioned to make the ball travel the shortest distance, the furthest distance? You can measure how far you can launch different objects using a ruler or a measuring tape. Try experimenting by moving the fulcrum from left to right. You'll notice when it's at its left position, the spoon is kind of close to the table and therefore it doesn't have as much room to store potential energy. But when we move it to the right, there's a lot more room for you to push down further, which means you can store more potential energy, which will result in more kinetic energy, and your ball should fly further. If you have any questions, please let us know. Make sure to log into Edmodo where you can see additional videos, interact with us, and enter our prize pool. A huge thank you to our sponsors for making this all possible: Barletta Boats, Gasca Tape Inc., the Rex and Alice A. Martin Foundation, Heimco, Welch Packaging, and Beacon Health System.